All right, in our first topic in domain number 1, our security and risk management domain, we are going to talk about the CIA triad. What is confidentiality? What is integrity? And what is availability? All right. So to start with, get rid of that. There we go. What is confidentiality? By definition, confidentiality is ensuring that information or function or intellectual property or personally identifiable information, whatever it is that we're trying to protect, is only seen and visible to the individuals that are authorized to see that information. A typical example of confidentiality would be the use of an encryption algorithm when we're sending or receiving data, like AES, the Advanced Encryption Standard. That is a perfect example of providing confidentiality for data in motion. Now, that doesn't necessarily mean that that's the only type of confidentiality that we apply in our organization. By definition, we use the least privilege principle, which is the principle of minimal privilege or the principle of least authority. That's by definition what it is. But what does that mean? That means that you're only allowed to see the information based on your job function, your role, based on, the privilege that you have to see that information. And minimal privilege means that we're only going to allow individuals to see information if they're authorized to see that information. But keep in mind, we're not simply applying this concept of confidentiality to, traditional data at rest, or data in motion. It could be confidentiality with, a schedule of events for a particular dignitary or an ambassador or a head of state, right? So that they don't, an attacker can't plan an attack to assassinate an individual because they understand what their detailed itinerary is or their schedule is. So again, as we go through this class and as we go through each of these domains, yes, there are some technical domains, but keep in mind that a lot of these concepts apply to not only to data, but they apply to other types and other forms of assets as well. So it's not just simply a matter of, using AES encryption or the Rindell algorithm to encrypt information as it's being transmitted across the VPN tunnel, right? Confidentiality could be simply as simple as locking something into a safe that requires, multiple factors of authentication to access. Confidentiality is a process, a user, a program. It can be applied to a process, a user, or a program. But the idea is that we're limiting access to only legitimate purposes. You're only going to be able to see the information or access the information if you're authorized to do so. All right. That access could be based on your job function. It could be based on your role within the organization, your involvement in a project or in the scope of the project, and so on. Identity theft is an example of an attack against confidentiality. So we're gaining access to personally identifiable information, social security number, date of birth, first, city you were born in, hospital you were born in, whatever it might be, that would give me the ability to either access information I normally wouldn't be able to access, or give me the ability to get access to information that I can use for nefarious purposes. In order for us to apply the appropriate level of confidentiality, we need to classify the data. There is a process and a procedure for ensuring data integrity, data confidentiality, non-repudiation. These are all terms that we're going to be going through as we go through this domain. But before we can do anything with the information, we need to be able to classify that information, because the number of controls, the level of control, the purpose of the controls, the administration of those controls are based on the data itself. Certainly we're not going to apply the same level of confidentiality to or classification to the lunch menu for the meeting that we're having today versus, the CEO's social security number. Access methods to get to or to access confidential information includes being able to authenticate users. Now, they do say identification, authentication, and authorization. There's a significant difference between identification and authentication. Identification is simply a statement of who you are. A username would be an example of identification. Presenting your driver's license to a police officer would be an example of identification. Stating your name on a conference bridge would be an example of identification. Authentication is the process of verifying that identification, ensuring that the credentials that are provided are valid, that if you state that your name is Scott Smith, that we're able to verify that you are Scott Smith. It could be through some sort of push notification that you have to interact with based on your cell phone or mobile device. It could be looking up a driver's license number in a centralized database to see if the driver's license is still valid, if you have any active warrants or anything based on verifying the authenticity of the information that was provided. So identification is really just a statement of who you are versus authentication, which is verification of identification. And then authorization, in this case, would be a way for us to identify the rights that you have. Now, with regard to confidentiality, that right could be the right to open a file, the right to access information in a filing cabinet, the right to access information in a storage facility, in a secure room or a vault or whatever it might be. Authorization is always going to be restricted to what you specifically need access to. It's not just simply, yes, we've identified who you are, so now we're going to go ahead and say you can do whatever you want because we've identified who you are. Okay? So confidentiality is not something that is new to you guys. You guys have been in the IT space for quite some time. You understand the general idea of confidentiality. Plus, we've lived life, right? We know that there are just certain things in life that we try to keep confidential. But again, try to stay away in this class from applying these concepts to one layer of understanding, right? I'm an IT guy, right? I've been in information technology for 30 years, and I'm talking about infrastructure, routing, switching, firewall, security, etc. So I tend to think of a lot of these concepts in that realm or in that scope. But again, these concepts apply to everything business related, particularly when it comes to CISSP. The next concept that we talk about is integrity, right? The principle that ensures that data is protected from unintentional or intentional, unauthorized, or accidental changes. Accidental would be the unintentional. Intentional would be, purposefully modifying information. All right. Now, again, data in this case could apply to data in motion or data at rest, data stored on a hard drive, or data being sent from point A to point B. But it could also apply to data that's being presented to the public for public consumption, data that's being shared by an engineering design team that's considered intellectual property, and that sharing method could be on a physical piece of paper, or it could be on, some sort of electronic, process or whatever. But the idea here is that what is being presented is what is received, right? Now, probably the easiest kind of way to describe this would be data in motion, sending a file, for example, from point A to point B. Now, the way that we verify integrity of a file is that we would use some sort of hashing process, cryptographic hashing process, where we generate a cryptographic hash of the data that's being sent. And then that cryptographic hash can be compared at the other side. It can be recalculated. We compare the hashes, and if the hashes match, we've maintained integrity of that information. Now, that would depend on how the data is being transmitted ultimately. But we'll get into the technical concepts of integrity a little bit later on. What is being sent is what is being received. That's ultimately the goal. Or what is being stated is what is being heard. That's ultimately the goal for integrity. Like I said, it could be files that are being transmitted or downloaded. It could be database entries. It could be entire systems. So monitoring the integrity of an entire system, the interoperations between components within a system or a network, and so on. An example of an integrity process being applied is the software development lifecycle, which is really just an application of standard business practices to building software applications. It's typically divided into 6 to 8 steps. You've got a planning phase, you've got a requirements phase, you've got a design phase. I'm trying to think of some of the others. A build phase. There's some sort of documentation phase as well. And then testing the application, deploying the application, and then finally applying the maintenance to the application. You may not have all of these phases. Some of the phases may be combined together. We may omit some of them. It depends on the scope of the ultimate project. But there are always going to be core components that are recommended in the development project, right? Now, the purpose of listing this here is not to go into the details of SDLC. We're going to do that later on in another domain. But this is just an example of a process that incorporates integrity. You imagine that software development, we're developing binaries and code and applications, and that's going to be an iterative process. It's going to be a kind of a cumulative process we have different teams working on different components of the application. So SDLC would fit into that, would include components of integrity. All right, we'll get into SDLC in more detail a little bit later on. Availability. All right, now this is a term that generally describes whether or not a system is usable or accessible. But I do want to differentiate that because I think it's important. There is a difference between availability and usability. Now, generally speaking, availability just means that something is accessible. When we think of availability, we think of things like, internet access, computing resources, servers or databases, active resources. But again, it doesn't necessarily mean that. It could mean availability of personnel, right? You have a pandemic and 20% or 50% of your staff gets infected and they have to quarantine. That becomes a lack of availability of resources. Somebody calls in a bomb threat, which forces a building to be evacuated for 3 or 4 hours. That's an attack on availability of physical resources because the building is no longer accessible and the assets inside of that building are no longer available to use. So again, it's not just the concept of availability for for technical assets, data in motion or data at rest. It's availability and accessibility to anything that's necessary for operations. Okay. They do mention a denial of service attack. We'll get into that type of attack in more detail later on, but it is a direct attack against availability, taking advantage of something that a system is designed to do by default, but simply overwhelming that system so that it becomes unusable or unwieldy, and it cannot be accessed or whatnot. Availability could be attacks against availability could be intentional. They could be unintentional. A backhoe digging up a fiber optic line to a facility. A water main breaks and floods the basement of a building or whatever. Those could cause lack of availability, or don't want to necessarily use the term attack, but certainly the lack of availability. Okay. Now, we do measure availability in a couple of different ways, right? There are several terms, and I'm not going to talk about them in detail right now. We'll get into them in more detail later on. But we talk about things like MTBF, the mean time between failure, MTTR, the mean time to recovery, recovery point objective, recovery time objective, and there's some other terms that we'll use to describe availability, right? Mean time between failure, in essence, is how long is something supposed to operate before we anticipate that it's going to fail, right? So that could be an estimated value. It can be a calculated value. But it is a measured value to say, okay, this system or this component or this function or this person is supposed to be available and working for, 6 months. And every 6 months we have to change out this system or whatever. Now, mean time would be an average time, right? Not necessarily the longest or the shortest time, but kind of the average time. A mean time to recovery is when the failure occurs, on average, how long did it take us to recover from that failure, right? So these values here are actuals. What I defer as an actual, meaning that these are values that we have calculated based on experience or based on what is happening in the real environment or the real world. Okay. RPO and RTO are goals. What I would define as a business goal or a business objective. What is our recovery point objective? What is our recovery time objective? A lot of times people get MTTR and RTO confused. MTTR, the mean time to recovery, versus the recovery time objective. You want to make sure that your RTO meets or exceeds, in a positive sense, the MTTR. If your RTO is 4 hours, meaning your recovery time objective is 4 hours, that is your goal. You're saying if a failure occurs, my goal is to recover within 4 hours, but your MTTR is 5 hours, then your policy fails because your actual average time to recovery exceeds what your objective was. Your mean time to recovery exceeds the objective. So again, you'll see these terms probably on the exam, and we'll certainly see them again. I was going to say I wasn't going to define them here, but I kind of already did. But we'll see them again. Doesn't hurt to see them more than once. The one I didn't do is RPO, recovery point objective. Probably the easiest way to describe that one is to describe it in the sense of, a backup scenario. You're backing up critical data within the organization. Those backups have to be maintained for a certain period of time, and they have to include a certain amount of data. So if you're doing backups every week, you want to make sure that your recovery point objective is not 1 day, because your recovery point objective is how much information do I want to be able to recover if there is a failure. If I'm doing backups every week, but my RPO is 1 day, then I'm not going to have on the 3rd or 4th day a backup of those changes because I'm only doing backups incrementally every week. So the recovery point objective is kind of like, okay, how much of this information do I want to recover in the event of a particular failure? Okay. Now, all of this, is kind of related to availability, because availability is a failure of a particular system from an operational standpoint. Downtime plays into this, the impact of downtime. We measure the importance of availability based on day-to-day operations. You always kind of hear that general concept of, it's, we're down for, 3 days. It's going to cost us $1 million a day. So we're going to make sure that we put in mitigating controls that reduce our exposure to that downtime, but we have to make sure those controls don't exceed the cost of what the downtime would cost, right? We'll talk about that in our risk analysis section a little bit later on. So they do mention here controls could include anti-malware detection, incident management plans, and disaster or business continuity plans. Right. If there's a flood, if a building becomes unusable because of a natural disaster, do I have a backup location? Do I have a backup building? Am I going to operate that as a hot site, as a cold site, as a warm site, etc.? All right. Does that make sense? So again, don't think of availability simply as a particular computing system or whatever. It applies to a bunch of different concepts within our organization: personnel, people, places, etc. So the CIA triad, again, kind of like just a visual representation of these concepts that we see: confidentiality, integrity, availability, and so on. All right. Now, there are other elements that we haven't discussed here: non-repudiation, other security-related concepts, but these are the cornerstones, if you will, of the security concepts that we talk about in this particular class.